I'm Anil Kumar. In this video, I'll discuss reflections on functions. In particular, we'll discuss reflection on x-axis in this example. The question here is, if f of x equals to square root of x plus 3, write an equation to represent y equals to minus f of x and describe the relation between the two functions. So what we have done here is we have also given you sketch of a graph. F of x equals to square root x plus 3. It is square root function moved 3 units left, right? So we have this point at minus 3. So that is the function square root of x plus 3. Now, the first part is write an equation to represent y equals to minus of f of x. So we are given f of x equals to square root of x plus 3 and y is equals to minus of f of x. It really means minus of square root of x plus 3, right? So that becomes the function y, which is minus of f of x. Now, what we can do here is we can plot the minus of f of x function taking few points and then see how these two graphs are related. So let us calculate the value for the new function, right? So we'll take some x values and calculate the value for minus of square root x plus 3. So I'll just take, we have marked 3 points here, which are good points to take. The first one here is at x equals to minus 3. So if I write x equals to, minus 3 here, in that case we have minus of minus 3 plus 3, and that is indeed equal to 0, right? So we get a point which is same. So let me mark this point here with a circle, which is minus 3, 0, right? So this is the point minus 3, 0. Now let me take another point at minus 2. So minus 2 will give us negative of, we are substituting x as minus 2 plus 3 square root, that is 1 with a negative sign. So that is minus 1. So that means at minus 2, the coordinate point y value is minus 1. So at minus 2, it is minus 1. So there it is, right? So that is the point for us. Now we'll take this particular point which is at 1, okay? At 1, the value is minus of 1 plus 3 minus 1 plus 3 is 4, square root of 4 is 2, so we get minus 2. The coordinate point will be 1 minus 2, correct? So 1 minus 2 is this point. Now connecting these points, we get our graphs. So it will be kind of like this. Okay, so that is the graph which is for the function minus square root of x plus 3. You could take more points, right? Especially 5 and 3 is a good point to take. Okay, and then you'll get fairly accurate graph. Anyway, what do you observe? What we see here is that we do have a point which is same on both the graphs, and we call that as an invariant point. So in our case, minus 3, 0, which is x-intercept, this point is same, so we call that as invariant. So we do have invariant, and that is the point on the x-axis. The other points which you can see are kind of reflected on x-axis. So other points are reflection on x-axis. So all other points, they are reflected. So this distance is same. Do you see that? Now here also this distance is same, and that is a reflection on the x-axis, right? So that is what happens when we consider negative of f of x. So in general, we can say a relation is that graph of f of x is reflected on the x-axis to produce graph of minus f of x. This is kind of very important to understand. Correct? Now with this, all the changes in the characteristics come. Major change here is that the range changes, right? So we can write down the change is that earlier domain is same. Do you see that? Domain remains same. So that is important. However, what happens to the range? Now since the y values are changing, right? So let me make a note here. What is really effect of this reflection is that a point which is, let us say, xy, it changes to x with minus y. Do you see all these y values? They're kind of negative for the same x values, right? So 2 will be here, right? So this, you see that reflection. So y values change. Since the y values become negative, the domain remains same because x values are same. Y values change means that the range changes. Do you see that? So the important change here is range changes. So range changes. So now the range is that y belongs to real numbers, but y is not greater than equal to 0, it is less than equal to 0. So that again, it flips. That is a major change. So another way of saying this is that instead of when x approaches positive infinity, y approaches not positive infinity but negative infinity, right? So that is sometimes called end behavior, which we write as, so in this particular case, when x approaches positive infinity, y approaches negative infinity for minus of f of x. Do you see that? So that is another major change which happens. However, both the graphs are congruent, right? So it is important to note that both the graphs are congruent, right? So we have congruent graphs Of course, it is just a reflection. So reflection of an image will be exact replica, right? So therefore, the graphs are congruent. However, the end behavior changes. That is to say, when x approaches positive infinity, y approaches negative infinity for y of minus x. So these calculations show us very clearly that whenever we are taking negative of a function, then it could be sketched directly by reflecting the function on the x-axis. Its domain always remains same, however, the range will get reversed. There will be invariant points, that is, the points which will not change, and these are the x-intercepts. All other points will change, and the transformation will be if x and y are the coordinate points on f of x. In that case, in minus f of x, the coordinate points will be x and minus y. I hope with this, the concept of reflection or y equals to minus of f of x is clear. We'll take now a few examples to discuss horizontal reflection. I hope that helps. I'm Anil Kumar. You can subscribe and learn a lot from my videos. Thank you and all the best.